Hi, this video has been requested by Owen, who would like to revise some ideas about static electricity. In this video, we're going to look at some of the uses of static electricity, including photocopiers and electrostatic precipitators, and also paint spraying. We're going to explain how some of the little tricks you can do with static electricity work. And we're also going to look at some of the inconveniences of static electricity and some of the irritations of static electricity and some of the dangers of static electricity, all to come in this video. So let's start with the basics of the atom. There's two charges that are important for our static electricity work. Inside the nucleus, the positive protons, and out on the energy levels, the negative electrons. They're important in explaining our ideas of static electricity. So, insulating materials like plastic start with no overall charge. They have an equal number of protons and electrons. But if you rub that plastic rod, for example with a cloth, you can start to transfer the electrons. It's only electrons that move, protons stay put. So if you rub the plastic rod with a cloth and electrons move from the cloth onto the rod then has more electrons than it had protons. Therefore, overall, it has a negative charge. If you think about the cloth that you were rubbing with, it's given electrons away. They've transferred because of that force of friction. When the electrons transferred away from the cloth was left with less electrons than protons, and so the cloth has a positive charge. Charges can be transferred by the force of friction. Only insulating materials can be charged with static electricity, because insulators hang on to their electrons. They stay static, they stay still in one place. Conductors allow the flow of free electrons, and therefore electrons would be able to flow through a conductor and down to Earth, say. They wouldn't hang about and stay static. So, we can transfer electrons from one object to another. If an object gains extra electrons, it becomes negatively charged. If an object gives away its electrons, it is left positively charged. But what happens when positive charges come together, or negative charges come together, or positive and negative charges come together? There is a rule. Like charges repel, so if they're the same charge, they repel, and opposite charges attract. If a positive and a negative come together, they want to stay together. It's because of this rule that like charges repel that you get a bad hair day when you pull your hat off. As you pull your hat from your head, the hair and the hat rub together. Electrons are transferred, for example, from the hat to your hair. Your hair becomes negatively charged, and each strand of negatively charged hair is trying to repel another strand of negatively charged hair. But also your hair is attracted to your positively charged hat, hence the bad hair day. It's time for a pause. You're going to pause the video and you're going to try and explain why a balloon can stick to a wall when you've rubbed it on your hair. Have a go and then check your ideas with my explanation. So we start with a neutral, no overall charge on the balloon or the hair. You rub the balloon on the hair, and because of the force of friction, electrons can be transferred from the hair onto the balloon. The balloon now has more electrons than protons, so it's negatively charged. The wall has no overall charge. It has an equal number of protons and electrons. But as the negative balloon comes near to the wall, the electrons are repelled round to the other side of the atom. The protons shift over, attracted, still in their nucleus, but attracted nearer the surface of the wall, and the balloon is held in place by the electrostatic attraction between the electrons in the balloon and the protons in the wall. The The same sort of thing can be seen if you rub a balloon on your hair and then hold it near a stream of water from the tap. The water will be attracted towards the balloon in the same way the balloon was attracted to the wall. So it's time to start looking at some uses. Static electricity can be really useful when you're using a paint sprayer. The nozzle is charged and the object is charged, but they're given opposite charges. So as the paint comes through the nozzle, the paint gains the negative charge. As it gains the negative charge, each droplet of paint tries to get away from each other. It's repelled, forming a nice fine mist of paint. The object that you're spraying has the opposite charge, and therefore the paint is attracted to it, wasting very little paint and giving a nice even finish. Static electricity can be used in an electrostatic precipitator. It's used to remove harmful smoke particles from waste gases before they pass out of the chimney. Smoke particles become negatively charged as they pass through the metal grid because they gain electrons. The negative smoke particles are then attracted to the positive plates because of the unlike charges rule. The smoke particles will transfer their excess electrons to the plate, which is connected to Earth, and so the particles will discharge, and then gravity will pull them to the collecting plate. But static isn't always useful. For example, I often give myself a little static shock when I get out my car. As I slide across the seat, electrons get transferred, and then when I touch the conducting metal car, those electrons quickly rush through me. Let's use this example to consider the flow of charge. Imagine I lose electrons to my car seat. If I transfer electrons to the car seat, I'm left positive. So when I touch the metal car, the electrons will flow through the car to me, causing the shock. That's a rate of flow of charge, a rate of flow of electrons. That's electric current. A danger of static is lightning. Storm clouds contain charges. The top of the cloud has a positive charge, and the bit we see, the bottom of the cloud, is negatively charged. That negative charge can charge up the air around the cloud. This can cause electrons to jump to the Earth, ionising the air. And as the air is ionised, this causes even more electrons to make the leap, causing the spark. That flow of electrons is an electric current. The current heats the air super quickly, which produces a little pressure wave, which is the sound you hear. The ions created in the air recombine with electrons in the air and emit the energy as light. To protect tall buildings, lightning conductors are used, so that if the air around the cloud gets charged, the cloud will attract positive charge from the lightning conductor and repel electrons away to Earth. Eventually, the spark that happens between the negative cloud and the positive conductor can happen without hitting the building and causing damage. When refuelling a vehicle, like a car or an aeroplane, electrons can be transferred as fuel flows along the fuel pipe. This can cause a build-up of negative charge. A bonding line needs to be used to connect the vehicle to Earth, giving the electrons an easy route so they can't build up in one place. If the charge does build up in one place, then there's the danger of a spark, just like lightning, and then kaboom! Let's finish by looking at the photocopier and how it uses static electricity. The page you want to copy is placed on the glass screen, and an image is projected onto a positively charged drum. The drum has a coating that conducts electricity when light falls on it, so the parts of the drum that are lit by the projected image lose their charge when they start to conduct. The black powder toner is negatively charged, so it's attracted to the positive bits of the drum. The drum rolls, transferring the toner onto the piece of paper, making a black and white copy of the original. and the paper is then heated to stick the toner to the paper. So that's it. That's our revision of static electricity, my last YouTube video for 2016. Thank you for all your support and positive comments on the start of my YouTube experience. I very much hope to make some more revision videos for 2017 because you know that
regular review gets a better grade for you.
Don't forget to
Like,
so that I can keep making the videos.
comment,
Especially to request other revision topics.
subscribe.
So you can get notifications of when my next video gets uploaded.